We're going to use the calculator and what we've learned so far. So today is January 10th. Again, your notes should have the date and they should have a title. We are graphing general rational functions. And today we have slightly harder functions, but they're not really. We're going to use our calculator to help us out a little bit more. So hopefully, I see most of you have those graphing calculators. Again, there are more graphing calculators down in the finance office. They're Casios. They look like this one. And you can check them out. I put 22 of them down there, and they were ready to go. So go get them before they run out. And if not, this is $40. $40. Totally worth it. Okay, Amazon. And I hear someone's music. Someone's got earbuds in. I can hear them. Okay. So first question here. Is this simplified or not? How do you know it's not simplified? There's an X on top. Yeah, because there's an X on top. That's like something that can be reduced. Okay? Because of that, we're going to do a tiny bit of long division here. My divisor into 2x plus 4. How many times does 2x go into 2x? One time. And then we're going to distribute. 1 times 2x is 2x. 1 times negative 3. Negative 3, good. And then we're going to subtract everything. 2x minus 2x is 0. 4 minus a negative 3 is 7. All right, this is the remainder. What is 2x minus 3? Divisor. What is the 1? Quotient. Very good. So we can rewrite this expression as quotient plus remainder over divisor. And this is the simplified form. And the nice thing is when we're in the simplified form, we can find that vertical asymptote and horizontal asymptote. Where does the vertical asymptote come from? The denominator, yes. 2x minus 3 gets set equal to 0. How do we solve for x? Move the 3, so we get positive 3, and then divide by 2, we get x equals 3 divided by 2. X equals 3 halves. 3 halves is 1.5. That is our vertical asymptote. It always comes from the denominator. And you can get it from this denominator or that one, either one. They give you the same thing. What's our horizontal asymptote? That quotient there, whatever that quotient is, happens to be our horizontal asymptote, y equals 1. We can go and make a little sketch here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we can graph our asymptotes. So we always want to get those asymptotes first and plot those, and then we can move to the next step. So 1.5 is right here, and we want a vertical line through that on the x-axis. Y equals 1 is right here on the y-axis, and we want a horizontal line through that. So we have our asymptotes there, and now we want to find some x and y ordered pairs to plot, and that's going to help us graph. Since we know our vertical asymptote, we're going to choose a point to the left and point to the right. What's to the left of 1.5? 1 is a great choice, and what's to the right? 2. Okay. All of this is what we've been doing. We can plug in the 1 if we want, or we can use our calculators. So I want to show you how to use your calculators. We are going to plug in our function. These two expressions are equal. They are equivalent. They're just different forms. One is an improper fraction, and one is a mixed number. 1 1/3, a mixed number, okay? So they are the same. However, this one we did ourselves, and so we could have made a mistake. So what I'm going to do is I'm going to use the function that they gave us, and I'm going to input this function into my calculator. You need to put parentheses around the numerator and parentheses around the denominator to make sure your calculator knows what is on top and what is on bottom, okay? That is rule number 1 of using your calculator. Always, always, always. You got it? Okay, now we need to put this in Y1. So I know there's a couple of different kinds of calculators we have here today. So I'm going to try and use both. If you have a TI, you're going to go to the Y equals menu and type in your equation using parentheses. The X is right next to the alpha key. 2x plus 4 divided by parentheses 2x minus 3. All right, that's there. If you have a Casio, it's very close. We're going to turn it on, and you can go to menu, and you have different menus. We want the graphing menu. So move to the graphing menu, hit execute, so that you're in your Y equals menu. How many Casios do I have? Does anyone else have a Casio? Okay. Yours is not dark. Okay. Well, no one has a Casio. Is that right?
I have one.
You don't have it with you. Okay. So very similar here, but the X is right here under the alpha key. So that's the X you would use. And so we would type in 2x plus 4 divided by 2x minus 3. 2x minus 3, and hit enter. On the Casio, when you hit enter, you have these menu options. And this one says draw. And so if you press draw, there's the graph. And on our TI, it's best to start to do a zoom, the zoom menu, and 6. Zoom 6 is a standard window. Zoom 6 is usually a good window to go to. You can press graph as well, but Zoom 6 takes you to a regular 10 by 10 window. Okay? Are you all good? You're all with me? Okay, so this is the shape of the graph. These are the hyperbolas that we've been drawing, that L-shaped thing, okay? Now, here's the best part of these calculators. You know how we've been plugging in a number for X and figuring out the Y? Your calculator is going to do that for you today, okay? It makes it so much easier. And so we want to figure out how to plug in the value X equals 1, and it's going to give us this Y value, and that's using trace. Both of these calculators have a trace menu. On the TI, trace is right here. You just push trace, and you're going to type in the number. We want to type in 1. And you can see X equals 1 right there, and hit enter. And there it tells me the output is -6. So 1, -6. And then you can just keep typing to enter, to 8. All right. Casio is the same. The trace menu is right here in yellow. So we would do second trace, and same thing. If we plug in the 1 and enter, you get -6, and 2 and enter, we get 8. All right. And so we can plot those points and then make that L shape for our function. 1, -6 is right here. And we draw our little L-shaped hyperbola. And 2, 8 is like here. And we draw our little L-shaped parabola. Okay. So now you know how to use the trace menu on your calculator. Really useful, okay, for finding ordered pairs, which is a big hint on your test. You look at a graph, you find an ordered pair, okay, and then find the function that has that same ordered pair. Yeah, okay. So let's try it. We have slightly different functions today, but same ideas. So here we go. Example 1. Identify the vertical asymptote, horizontal asymptote, and graph. Identify the vertical asymptote, horizontal asymptote, and graph. Remember, I need these things in your notes. Example 1 and directions. Very important. I need those directions. What is different about this equation, about this function? There's what? 3 on the bottom? Oh, 3 terms on the bottom, yeah? Okay. 3 terms, and this is quadratic, yeah, squared. It's quadratic. That's the function type we have today, where we have a quadratic on the bottom. And because of that quadratic on the bottom, that's something that whenever we see a quadratic, we want to factor first, okay? So today and on Monday, we'll be doing a lot of factoring again, because anytime you have quadratic, we're going to try and factor it. All right, we get tons and tons of information. So I want to go ahead and factor this denominator. What times what is x squared? You can say it out loud. I know you're thinking it. That's an easy question. X times x. And then we say what times what is negative 4? What times what is negative 4? Negative 2 and positive 2. What else? Negative 4 and positive 1. We want negative 4 and positive 1. Why? Yeah, it gives us that negative 3 when we add them together. All right? So negative 4 and positive 1. Now, we are going to solve each of these bubbles. So x minus 4 gets set equal to 0. Isolate x, what do we get? X equals 4. If we move that 4 over. Here, same thing. X plus 1 equals 0. Isolate the x, what do we get? X equals negative 1. Guess what we just found? We just found our vertical asymptotes. The vertical asymptotes always come from the x's in the denominator. So we have x equals 4 and x equals negative 1 for our vertical asymptotes. Always, always, always from the denominator, okay? There are 2 vertical asymptotes in this type of rational fractional function. So horizontal asymptote is a little bit different. On the previous example, on the do now number 1 here, this function could be reduced by division. All right. Can this one be reduced? No, it cannot. Why? Yeah, there's just a 2 on top. There's no x's that I can reduce out. I cannot do long division. So this is like asking yourself, how many times does 12 go, or not 12, how many times does 13 go into 2? Can you do that? That doesn't work, right? It goes in 0 times. This one cannot be reduced. It's already in lowest terms. And so all of our functions today have a constant on top, which means we can't do any long division. So all of our asymptotes, horizontal asymptotes are at y equals 0. All right, we're going to go ahead and start graphing what we know. All right, so I have my vertical asymptote at 4 on the x-axis. I'm going to draw my vertical line. I also have vertical asymptote at negative 1 on the x-axis. And I have a horizontal asymptote at y equals 0. It's a horizontal line. It's right on the axis. You can see that by drawing in these asymptotes, I'm sort of separating my coordinate plane into 6 little sections. All right? We're going to fill up about half of them with our graph. All right? Just like before, we need some values for x and y. So we're going to create an xy chart. Just like before, we choose our x values based on our asymptotes, our vertical asymptotes. So I'm here at -1. What's to the left? -2. That's a good number. What's to the right? 0. Here I am at 4. What's to the left? 3 is a great number. And what's to the right? 5. So these are our x values that we want to find the outputs for, and we're going to do that with our calculators. So now in your calculators, again, parentheses is paramount. We need parentheses around the numerator and parentheses around the denominator. So we're going to go take our calculators and go to y equals and delete our function, and then use parentheses. 2 divided by x squared minus 3x minus 4 with all of those parentheses. Once you get that in, you can go ahead and just hit graph. Are you doing it? Do it. You got it in already? And hit graph. You can see this graph is an interesting shape. Look at that. It's got our little hyperbola here on the top left. It's got, what's this shape? Like a U, right? It's a parabolic shape because this is quadratic. So it's got a little parabola in there. And then it's got our L hyperbola here on the right side. We're going to use trace. We're going to use the trace menu to figure out our y values. So I'm going to use trace and type in -2. Enter. We get 0.33. We plug in 0. Hit enter. -0.5. Plug in 3. Hit enter. -0.5 again. You notice some duplicates. Okay, you should see that. 5. Hit enter again. 0.33. So now that I know those ordered pairs and I know what the shape should look like, I can mimic that here on my graph. -2.33 is just a tiny bit above, and I can then draw my L-shaped hyperbola through that point. 0, -0.5 is just a tiny bit below 0. And 3, -0.5 is just a tiny bit below 3, and I can connect those with a nice smooth U shape. And 5.33 again is just a tiny bit above, and I'm going to connect it with a nice smooth hyperbola. And that's it, ladies and gentlemen. All right, using your calculator is huge. So again, if you do not have a graphing calculator, get one. All right, go to the finance office and check one out or spend $40. It's worth it. Do you have questions for me? John. So yours is just an older model, but that is correct. You can see what you're seeing is actually it's trying to sort of draw an asymptote in. So you still see that little L and the U and the L shape. Okay. Yeah.